Hi everyone, this is our introductory lecture video 2, section 1.3, where you are introduced to trigonometric functions. Now, the very beginning of this section, you are reintroduced to the Pythagorean theorem. Let's suppose you have a right triangle with sides A and B and hypotenuse C. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In other words, a squared plus b squared is equal to c squared. This comes into play quite often when dealing with trigonometric functions. Maximus, I'm in the middle of doing my job. Up next, we have the distance formula. Let's suppose you have 2 points in a coordinate plane, and you were asked to find the distance between those 2 points. Let's call these points P and R, respectively. The distance between 2 points is given by the following formula. It is the square root of the sums of the squares of the difference in the x's and the difference in the y's. So how are trig functions defined? With the geometric definition of a trig function, you have the following. Let's suppose that you have a point in a plane, and you want to find the 6 trigonometric functions that are associated with that point for a given angle theta. To define the 6 trigonometric functions, we start with an angle theta in standard position, and choose any point P having coordinates x, y on the terminal side of theta. Remember that the terminal side of theta, this is where the angle ends. We will find the distance from the origin. Maximus, I love you, baby boy, but I gotta do my job. Who's a good boy? Okay. We will find the distance from the origin, denoted by O, to the point capital P, and we will call this distance R. So remember how to find the distance between 2 points. You look at the square root of the sums of the squares of the difference in the x values and the y values. The origin has coordinates 0, 0, so we plug that into our distance formula, and you end up with the following. So this R, this is a distance from the origin to a point in the plane, and it is the square root of x squared plus y squared. So for a point x, y, other than the origin on the terminal side of an angle theta, the 6 trigonometric functions are defined as follows. Your sine of theta is equal to the y coordinate divided by r. Your cosine of theta is equal to the x coordinate divided by r. And your tangent of theta is defined to be the y coordinate over the x coordinate, provided that x does not equal 0. Your reciprocal functions are defined as the reciprocals of sine, cosine, and tangent, respectively. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Maximus. Who's your good boy? So let's take a look at a quick example before we end this video. You are asked to do the following in this problem. You need to sketch an angle theta in standard position, such that theta has the least positive measure and the given point is on the terminal side of theta. So what does it mean for theta to have the least positive measure? So it's asking you to draw the angle theta associated with the point, and it is the smallest positive angle that you can draw. So your point is 5, negative 12. So this is your point. And theta is supposed to be in standard position. That means it starts at the positive x-axis. And it has to have the least positive measure. So your angle theta associated with this point here is going to be this angle right here in the red. This question then asks you to find the values of the 6 trigonometric functions for this angle. Okay, so how do I do this? So if I look at this triangle here, this is definitely a right triangle. Let's pick up that triangle and put it over here. What do I know about this triangle? I know that this small side is 5. The long side here, this is given by the y-coordinate, is negative 12. I need to find this hypotenuse, which is r. So using the Pythagorean theorem, I can find that hypotenuse. So we have 5 squared plus negative 12 squared equals r squared. From here, you should end up with r squared equals 169. So r is equal to 13. Remember that the r, the distance from the origin to the point, that has to be non-negative. So be sure to take the positive root when you take the square root of 169. So from here, I have to find the 6 trigonometric functions for this point and that given angle. So I have the x, I have the y, and I have the r. So let's find these trig functions. So sine of theta equals y over r. Your y is negative 12. Your r is 13. Cosine of theta is equal to the x over the r. Your x is 5 and your r is 13. Tangent of theta is equal to the y over the x. So this is equal to negative 12 over 5. And the last thing that we'll do here is find the reciprocal functions. So the reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So taking those reciprocals there, you end up with the following. Alrighty, everyone, that's going to wrap up this lecture video, and I will see you tomorrow.